Okay. All right. So, are you guys right in front of your computers? So just give me a thumbs up. All right. So 1, 2, 3, 4. Okay. So maybe we'll just wait 30 more seconds for the others. All right. So don't you guys worry. This one will only take maybe 10 minutes since this is already the last topic. Okay, the last part. Okay. So uh, I hope most of you are already in front of your computers or smartphones. So let us continue now with the sign binary numbers. So again, if we want to send a positive number in our computer, so all we need to do is represent that one by using a zero. Okay. But if we want to represent that binary or that that number into negative, then we have to make that zero into one. Okay. So if you guys are going to take a look on this one, the first 4 bit is the value, and then the second 4 bit is the sign. Okay, so if it's positive, then just make it 0. If it's negative, then just make it 1. Okay, so are we clear so far regarding with positive 9 and negative 9? Okay, very good, Miss Karil. How about the others? Okay, so at least 4 of you were able to get it. Anyway, so this is just the concept, okay, on how we're going to represent positive and negative into our binary numbers. So in here, okay, so it's a different thing with our computers. Okay, this is not what we're going to use, but we're going to use the two's complement. All right. So it's kind of the same. So 0 for positive and then 1 for negative for the most significant bit, but just a different process. So we're going to apply two process. Okay. So before, if we have this -9 wherein we have 1 0 0 0 1 0 0 1, in computer it is now in a form of something like this. Okay, 1 1 1 1 0 1 1 1. Okay, this is actually the actual conversion or the actual uh, sequence or numbers when it comes to representing -9. For the -13, we have this value 1 1 1 1 0 0 1 1 1, and then for -6, we have 1 1 1 1 1 0 1 0. So yeah, I know that this one is quite confusing for now, but let me show to you guys on how did we get that 1 1 1 1 0 1 1 1. Okay, for the -9. Okay, so let's have this example. So how to derive 2's complement. So the first step that you need to do is represent that +9 into as usual. Okay, the +9 in binary bit. So we have this one +9, 1 0 0 1. So 8 plus 1 is 9. Okay, and then the next thing that you need to do is you have to apply two's complement. Okay, so you have to complement each bit. So how do we do that? So 1 will become 0, and then 0 will become 1. All right, so that's how we've got this result in here. So 1 became 0, 0 became 1, 0 became 1, 1 became 0. All of those zeros became 1. Okay, so that's the second step. And then the third one is, all you have to do is add 1. Okay, so this one is in binary addition. Okay, so just put here plus and then just put here 1. So 0 plus 1 is 1. And then just bring down everything. Okay, so this is now the representation of -9. So if you're going to take a look at this one, we have 1, 1, 1, 0, 1, 1, 1, which is now the same with this one. Okay, so were you guys able to follow so far? So we need 3 steps. So we need to represent that one, normally in positive, and then we have to apply 2's complement. 0 will become 1, 1 will become 0, and then third one is we have to, add 1, okay, using a binary addition. And then whatever is the result will now be the representation of that positive 9 into negative 9. Okay, so anyone who's confused? None? So how about give me a thumbs up if you guys were able to get this one? The concept or the idea on how to convert positive 9 to negative 9. Only one? Only Mr. Adrian? Okay, Mr. Ramji, Mr. or Miss 18? Mr. Ranjan, Miss Kyla, okay, Mr. Russell, okay. So at least half of you. Okay, so let's have one more example. Let's represent this negative 25 using this process. So we need negative 25. So the first step, okay, is we need to represent that one, in a normal way, okay, using a binary number. So we need 16. So 0, 0, 0, 1. 16 plus 8 is 24. So 1, 0, 0, 1. And then plus 1 is 25. So this is the representation of positive 25. So 16 plus 8 and then plus 1 is equal to 25. So second step, we have to apply 2's complement. Okay, so 0 will become 1, 1 will become 0. So 1 will become 0, 0 will become 1, 1 is 0, 1 is again 0, and then those zeros will become 1. Okay, and then the third step is we have to add 1. Okay, so plus 1. So 0 plus 1 is 1, and then all you need to do is bring down everything. 1, 1, 0, 0, 1, 1, 1. Okay, so this is now the binary representation of negative 25. Okay, so are we clear so far? Anyone? Wala nakakuha. Kanina meron lang ah. So who's confused again? Wasn't able to follow, and how did we get this answer right here? Miss Emily, okay, 1. How about the others? Mr. Ban Egg, Mr. Mard, okay, Mr. Rex. Okay, so 5 of you were not able to get this one. All right. So again, let's have another example. Let's represent this negative 46 in here into sign binary number. Okay, so let me just lower your hands. All right. So negative 46. So again, first step, I guess it's easier in Notepad. Okay. First step is represent that in normal binary combination. Okay. So in here, we are solving for the negative 46. So the first step is, have a binary combination equal to 46 in decimal. So this one is equal to, so we need 32. So 0, 0, 1, 0. 32 plus 16 is 40. So we don't need 16. Plus 8, 32 plus 8 is 40. So we need 6 more. 4 plus 2, 110. Okay. So this is now the normal. Okay, this is now the normal representation of 46. So this one is positive 46. Okay. Second step is we have to apply 2's complement. Okay. So again, what happened? What is happening in 2's complement? So 0 will become 1. Okay, and then 1, masyado yata magulo. Yan, ganyan na lang. And then 1 will become, okay? So of course, vice versa yan. Okay? So let me just move this one right here. Oops, what happened? Okay. And then this one, so applying 2's complement. So 0 will become 1. There you go. And then 1 will become 0. 0 will become 1. So 1 will become 0. And then 0 will become 1. Okay, so this is now the second step. Third step is we have to apply, I mean, not apply, add 1. Okay, and then this add 1 right here is a binary addition. Okay, so in here, oops, third step is plus 1. Okay, so this one now is equal to, hindi ako pwede maglagay ng underline. Anyway, whatever is the result of this one is now your final answer. Oops, nawala. So 1 plus 1 is 10. Okay, so carry 1, bring down 0. Okay, so we have carry right here, so just bring it down. Just 1. There you go. Hirap yata, hindi sila align. Pero yan. And then the 2, 0. There you go. And then we have here 1, 0, 1, 1. So just copy as it is. Alright, so 1 plus 1 is 10. Carry 1, bring down 0. And then 1 plus 0 is 1. And then everything now is the same. Okay, so did you guys get it? All right. Okay, very good. Okay, okay. All right, so let's now move on to the next examples. So I will not answer this one anymore. Okay, let me just explain how did we get this one. So in positive positive, so of course, nothing special. Convert this one into normal binary combination, which is this one. The same with 13, and then just add it, using binary addition, and then you will get this one. But in here we have negative, so we have to represent this 13 right here into negative 13. So all you need to do is apply this one. Okay, so apply those 3 steps, and then you will get this result right here. And then from here you can now perform subtraction. Okay, since we are in subtraction. So 0 minus 1 is 1. 1 minus 1 is 0. 1 minus 0 is oops, wait. 0 minus 1 is 1. 1 plus 1. I'm sorry. Okay. So after that, you have to apply binary addition. Okay. So 0 plus 1 is 1. 1 plus 1 is 10. So carry 1, bring down 0. Then 1 plus 1 is 10 again. So carry 1, bring down 0. Okay. And then from here, we have, uh, oops. What parang magulo? Okay. Let me just confirm it. If it's really addition or subtraction. Okay, after representing it using 2's complement, So if it's addition, 3 plus 1 is 1. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 is 10, carry 1, bring down, huh? Wait a minute. 1 plus 1 is 10, bring down 1. But in here, okay, so it's correct. So you guys have to perform addition, okay? So 0 plus 1 is 1, 0 plus 1 is 1, everything is 1, okay? So not subtraction, okay? So all you need to do is represent this 13 right here into its negative 13 binary combination, and then apply binary addition. Then you will get this result right here, okay? So are we clear with that one? So the same with this example, you have to represent this 6 right here into negative binary combination, same with negative 13, and then apply binary addition. Okay, so clear so far? Or no? Okay, how about raise your hand if you didn't get it? None? So neutral kayong lahat? Okay, let me just repeat my question. So, is it okay or no? Okay, were you guys able to get it? Or maybe you guys are not in front of your computer anymore. Makain na kayo? Nagutom na? Lapit na tayo matapos. Hello, hello, hello. So is there still someone listening? So only one? Is there only
Yes,
Mr.
sir.
Giovanni? Okay, 2, 3, 4, 5, 6, 7, 8. Okay. So again, those people who are raising their hands didn't get it. Okay, so there's 3. Okay. So let's maybe perform one example. Okay, so let's have this one. Okay. Oops. All right. So let me just lower your hands. So again, you have to represent this one into its own negative binary combination. So how do we do that one? So we should apply 2's complement. So first step for positive 6, I mean negative 6, is we have to represent this one in a normal way. Okay, so 0, 0, 0, 0, 0, 1, 1, 0. So this is the positive 6. And then we have to apply 2's complement. So 0 will become 1, 1 will become 0. So 1, 1, 1, 1, 1, 0, 0, 1. And then we have to add 1. So plus 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 0 is 1. And then everything now is the same. Okay. So for the negative 6, we have this binary combination. 1, 1, 1, 1, 1, 0, 1, 0. Okay, how about the negative 13? Okay, so again, represent this one, in the positive 13, in a normal way of binary combination. So 8 plus 4 is 12. We need 1 for 13. Okay, so this is now the positive 13. And then apply 2's complement. So let me just put here. Apply 2's complement. Okay, so 0 will become 1 and then 1 will become 0. So 1, 1, 1, 0, 0, 1, 0. And then add 1. Okay, so plus 1. So 0 plus 1 is 1. And then bring down everything. 1, 1, 1, 1. So this is now the representation of negative 13 in binary combination. 1, 1, 1, 0, 0, 1, 1. So this is now where we are going to apply binary addition. Okay? So 0 plus 1 is 1. 1 plus 1 is 10. Carry 1, bring down 0. So 1 plus 0 is 1. 1 plus 0 is 1. And then here 1 plus 1 is 10. So Carry 1, bring down 0. So 1 plus 1 is 11. Carry 1, bring down 1. 1 plus 1 is 3, 1 is 11. So carry 1, bring down 1. And then 3, 1 again is 11. So carry 1, bring down 1. And then bring down this 1 right here. So let's compare if we have the same result. Okay, so we have 1, 1, 1, 1, 1. Oops, bakit parang sobra tayo? And then 1, 1, 0, 1. 1, 1, 1, 1. Okay, so maybe this is incorrect. So we need one more 1 in here, okay? Because in here there's another bit in here. So this is the fifth bit of this 4-bit group. So in here, 1, 1, 1, 1, 0, and then 1, 1, 0, 1. Okay. So yeah, there's actually correction with this one. All right. So are we clear now so far? Okay. So only one, only Mr. Pasito are able to get it. Okay, Mr. Giovanni also, Mr. Adrian. Okay. All right. So in here, all you need to do is perform two's complement on those negative numbers, and then perform binary addition, and then you will get the same result. However, this one is incorrect. All right. So again, another exercise wherein, of course, you have to convert this one into its own negative binary combination, and then you can perform addition. So actually, it's already indicated in here. So yeah, you can answer this one, or this will serve as your practice exercise. Okay. And then going back to to the main references in everything when it comes to how our computer reads information. So actually that one came from ASCII, or ASCII code. That is actually the American Standard Code for Information Interchange. Okay, so this one has a maximum of 128 characters, or in a form of 7 bits required. So this one contains control characters, or the non-printing or printing characters, which is of course letter, digits, and then punctuation. So when we see non-printing, those are the escape button, tab button, control buttons, Microsoft button, alt, control function, our arrows, home and delete, page down, page up, and so on and so forth. Okay, anything that we cannot see while typing is non-printing. Okay, I'm pressing Alt, but nothing's showing up, so that's non-printing. And then anything that is showing up, so letter, number, punctuations, okay, decimals, question marks, anything that you can see while typing, those are printing characters. Okay, so I hope that one is clear. And then here are the lists, okay, from 0 to 127. Okay, that's why we only have 128 characters in here. So 0 to 127. So here are the representation in decimal, in hexadecimal, in octal, in characters, and then their meanings. Okay, so in here for the, let's say, letters, okay, capital letters, so we have 65 to 90, okay, in HTML, and then 65 to 90 in decimal, and then 41 to 5A, okay, in hexadecimal, and then 101 to 132 in octal, and so on and so forth. So they have their own equivalents when it comes to decimal, hexadecimal, octal, and then HTML. All right, and then here are their meanings, the character. Okay, so this is the data, the decimal, hexadecimal, and the octal. This is the data that our computer can read. Okay, and then under character, those are the data that we can read. You know, uh, that's how we understand those representations. All right. So anyway, uh, just an exercise. Write apple in ASCII using decimal code. or in yeah, you can do that one. However, I will not do this one anymore since we don't have that much time anymore. So I would like you guys to have at least 2 hours and 30 minutes, or at least 2 hours, to do the quiz number two. Okay. And then we have here the register transfer operation, and then digital logic circuits. So for the register, this is the group binary cells that are responsible for storing and holding the binary information. And then the transfer operation is it is where being transferred the binary operation from one set of registers to another set of registers. So just basically we have two types of registers. So one that is accepting, and then the one that is storing the data. And then digital logic circuits is the one doing the uh, let's say the process. If it's addition, then this is the one adding that data. If it's subtraction, then this is also the one subtracting that data. Okay, so here's the graph wherein how our data is being represented by registers. So if I click JOHN or John, it will go to control area first, and then it will represented by 8 cells. So 8 cell for J, 8 cell for O, 8 cell for H, and then 8 cell for N. So that's why we have 8 cells in here. And then from here, it will be represented by binary. So this is the first 8 cell, second 8 cell, third, and then fourth. Okay. And then from here, this is now the one that is being read by our processor. And then of course, it will go back to our monitor as letter J, O, H, and then N. All right. So that's how data works, or goes in or being processed in our processor. Okay. So another thing when it comes to let's say calculator, so we have here the operand 1, operand 2. So here's the binary representation of 225, binary representation of 6, and then here's the operation. Okay, wherein in here it's being represented by this number for the operation plus. Sorry, this one. Okay, so hindi na pala siya pinakita. But in here, it's performing addition. Okay, so it will add those two binaries, and then will be represented into binary again. And then if you're going to convert this one, it will give you a value of 291 in decimal. All right. So yeah, that's it for the module 4. So let me just uh, have an additional announcement. So regarding with not this one. Okay, regarding with your laboratory number 5, uh, instruction right here. So this is a letter, and at the same time a database. Okay. So in here, upon doing this process, it will lead you in creating a file which is has an extension of DB or database, wherein it is the one that you're going to merge into this letter. All right. So basically, you're going to submit two file. Okay, the one that is being created just by following this step, and then this MS Word file. Okay. So for you to be able to submit one file, I would like you guys to convert this one into a zip file or a RAR file. So you have to compress those two files as one file. Okay, so that I will receive two files in total. All right. So yeah, I hope you guys were able to get the idea on how to do the hands-on number 5. So again, you're going to submit two files, but then again, you have to compress that one as one, so that I will only receive one file, and then I'll be the one who's going to extract it, and then yeah, uh, get the two files and that uh, extracted file. All right, so yeah, that's it for today, and maybe we'll meet again tomorrow. So I'm not sure yet, but if you're going to meet tomorrow, just an additional announcement, since we're not going to have another discussion anymore, since module 5 and 6 is more on self experience or self study modules. Okay, so any questions so far before we end our meeting? Questions or clarification?
Sir, pwede demo yung pag-compress.
Compress. Okay, so
Yes, sir.
let's compress. Oh, this is an example of zip or a RAR file. However, let's say I want to compress these two into one file only. So just highlight that two file and then right click. Okay, and then let's see, add to archive. And then in here you can choose RAR or zip. So any of those two will be okay. So RAR is fine, zip is also okay. So from there, just click OK. Okay. Well, of course, you have to change the name of that one. So let's say lab number 5. Okay. So just click OK, and then it will be compressed as one file. And then from here, say once I receive this one as your lab number 5, then I will just extract it into one folder. Okay. Wherein this one contains these two screenshot 109 and then 110. Okay.
Thank you, sir.
So you have to download, before I forget, you have to download RAR application. Okay. Or we call that one WinRAR. Okay, just download this one, download WinRAR, and then install it to your computer, just in case you don't have this application yet. So yeah. All right. So any other questions so far? None. Okay, so if everything's clear already, then you can just leave a thumbs up and then you may now leave. However, if you have a question, so feel free to raise your hand since we still have 8 minutes, I guess. Okay, so to those who gave me thumbs up, so you guys may now go. And then just wait for my further announcement. Okay, so goodbye and see you guys to our next meeting. Okay, okay. How about the others? Miss Denny, Miss Nomi, Mr. Mard, Mr. Pasito, Mr. Langpawan.
Bye,
Questions?
sir.
Okay, goodbye. Goodbye and thank you too.